everyone, I'm Ashok. Welcome to another video on Machine Learning Data Science Terminologies series. In this video, we look into bias variance trade-off. Alright, so bias variance trade-off is used for optimizing your algorithm. To give you a very high level idea, so when you train an algorithm, the model complexity can be increased by fine-tuning certain hyperparameters. In neural networks, we can increase the number of neurons, number of layers. In ensemble techniques, we can increase the number of estimators and can decrease the learning rates, make it more complex. So when you make the model more complex, the model tends to fit for the training data very well. Let's say this is your accuracy, for example. The accuracy of the training data might start from, I don't know, 40 for very simple model, and it can keep on increasing. Okay, so let me just draw model with a little bit more space. Okay, so this is your model complexity, and this is your accuracy of the model. So when you increase the model complexity, your training data tend to fit further, and let's say this is your 100%. This is your 100% accuracy. So it tend to fit actually tend towards the 100%. Okay. At the same time, your testing data, which is an evaluation data, the new data, will gradually increase. At some point of time, it starts falling apart because after this, the model is too tightly fitting to the training data. Right. And this point where you have a maximum training and testing accuracy can be called as optimal model. So this is actually called as optimal model. Okay. In other words, after this, your training data efficiency might increase. So let me just write it down clearly. So this green line is a train accuracy, and this red is your test accuracy. But for the test data, the accuracy is falling down, which means that this model is not useful because the whole point of machine learning is to model a algorithm which basically learns from the training data and it predicts for the new data coming in. So that's why the machine learning prediction actually works. But in this case, the model is too tightly fitting to the training data. It's not very helpful for the testing data. So this region is called as overfitting. This is a overfitting region, and this region is underfitting. Underfitting is the model is not well fitted yet, so there's a scope for improving the accuracy. So the point which we see here is this is called as an optimal one. Okay. From a testing data perspective, you see that errors are actually higher and it actually goes down at this point it's lower and actually it's going up again over here. Okay. And I'm going to draw this bias square, which is a deviation of the actual value with the prediction. So the bias is very high over here. And as it goes further, the bias actually comes, this is bias square. Okay. And whereas the variance is other way around, this is variance and this is bias. And for any model, the error of any model can be mathematically split into three parts. One is bias square, and second one is variance, and third one is error which cannot reduce, called as irreducible error, or I can say irreducible error. So the error which is like kind of you cannot do anything about it. All right. Okay. So the region which is on the underfitting side is called as high bias, low variance. So this region, this underfitting region, is called as high bias, low variance, which means it actually has a scope to fine tune the model further, increase the model complexity. And this region, which is in the overfitting side, is called as high variance, low bias, which is not helpful because the model is tightly fitted to the training, but for the new data, it's going to give you poor accuracy. So our goal is to find this point where both bias and variance are at the minimum levels. This point, okay. And that's what we call it as bias variance trade-off. And the whole goal of machine learning fine-tuning is to find that optimal point where you trade off between bias and variance to provide the better accuracy, the complex model to the level that it is not going into overfitting and it does perform, it has the highest accuracy both for training as well as the testing data. Or in other words, both your bias and variance are optimally lower. Okay. All right. So that's the bias variance trade-off. I have a complete video on bias variance trade-off, which explains in more detail. I leave that link in the description for you to check out. Thank you very much for watching. If you like this channel, please subscribe and click notification button. I'll see you in the next video.